So hi everyone, in this video we will be talking about Dijkstra algorithm. So Dijkstra algorithm is used to find the shortest path from source node to a particular vertex. Now let's understand how it works actually. So you will be given a source, node. Now what you need to do is you need to find the shortest distance to every other vertex. Like from source node to every other vertex, you need to find the shortest distance. Now what we will do here is we will assume that the shortest distance from source node to every other vertex is infinity. So we will assume this and we'll assign like to reach 1 from 0 is it's infinity, it's infinity, and so on. And we know that we are at the source, so the distance to reach source would be 0, right? Because we are at that particular starting point, so it would be 0. So what we need to do here is we are at this particular node, we will find its adjacent nodes. So its adjacent nodes are 1 and 2. So these are its adjacent nodes 1 and 2. Now I'll check like how much distance I'm taking to reach 1. So the distance that I'm taking is 0 plus 4, that is 4. This is the distance that I am taking to reach 1. And this distance is less than the distance that I have assumed, so I'll change this to 4. I'll update this. Now again the other adjacent is node 2, and to reach node 2 I am taking 8, and 8 is actually less than the infinity, so I'll update the distance to 8. Now after this I need to check which is the minimum distance so far. So minimum distance is 4, so I'll go to this node, and I'll check for its adjacent nodes. So its adjacents are 0 and 4. Now if I go to 0, how much distance I will take? So I have 4 and the cost is 4. 4 plus 4, it's 8. But 8 is greater than 0, so I will not update the distance because I need the shortest, I need the minimum distance, right? And the other adjacent is 4. And how much distance it will take? It will take 6 plus 4, it is 10. And 10 is less than infinity, so I'll update it to 10. Correct? And after this I'll check which is the minimum. So the minimum is 8. So I'll go to this node, I'll go to this particular node, and I'll check for its adjacent nodes. So its adjacent is 0 and its adjacent is 3. So the distance to go to 0 would be 8 plus 8. So that would be 16, but 16 is greater than 0, so we will not update this. The other adjacent is 3, and the distance to go to 3 would be 10, which is less than the infinity, so I'll update it to 10. Now I'll check which is the shortest, which is the minimum. So it's a tie, so they both are 10, so I'll go with the ID of the vertex. So this 3 is less than 4, basically 3 is less than 4, so I'll go to this index, I'll go to this particular node, sorry, and I'll check for every other adjacent nodes. So 3's adjacent is 2 and 4. To go to 2 I'll need 10 plus 8, 18, but 18 is greater than 8, so I'll not update this. And to go to 4 I'll need 10 plus 10, 20, which is still greater than the distance that we have, that is 10, so I'll not update this. So as you can see, the distance to reach every other node from the source node is, like, let's say this is 0, this is 1, this is 2, this is 3, and this is 4, right? To reach 0 we need 0 distance, correct? And to reach 1 we need the distance 4, the minimum distance would be 4. And to reach 2 the minimum distance would be 8, and to reach 3 the minimum distance would be 10, and similarly to reach 4 the minimum distance would be 10. So this is how Dijkstra actually works. Now let's understand how we could implement this. To implement this, what we need is, first thing that we need is adjacency list. We need the adjacency list. What else we need? We need data structure that gives us the minimum distance every time. So for the ease of use, we will be using priority queue. So inside priority queue, what we will do, we will pass a pair of the distance so far and the node, correct? So this would be the priority queue. And one other thing that we need is the distance array, where we'll store the distance of every other vertex or node. Initially it will be the infinity, so for the source node it will be 0. Let's say the source node is 0, so for 0 the distance would be 0, and for every other initially it will be infinity. And as we go on in the traversal, we'll update the distance as we get the minimum. So this is how we will implement this. Now let's try to code this, and then I'll explain everything. So first thing that we need is an adjacency list. Let's create one vector of vectors of, and the adjacency list will contain the adjacent elements and the cost of the edge. Like it will contain the adjacency of 1 and the cost, that is 4. So we'll take the pair of int comma int, and yeah, so let's call this adjacency list adj. adj of size capital B. Okay, now we need to create this adjacency list. So we have they have given us the edges. So what we will do, we will iterate over these edges. Let's say edges. So we'll be iterating over these edges, and what we will do is we will push back adj of e comma 0 dot push back. I'm pushing the pair, so it will be e of 1 comma e of 2. Now let's understand. So in the edges section, so this will be u, this will be v, and this will be our weight. So what I did is I'm pushing at this particular index, I'll pushing at u the v and its cost, and I'll do the same for e of 1 push back, and I'm pushing e of 0 and the cost is e of 2. Why I'm doing this? Because it's an undirected graph, so undirected graph is bidirectional, so we also need to store that, so that's why I did this. So that's how you create the adjacency list. Now after this, what else do we need? We need a priority queue. So let's priority queue, and inside priority queue, what we need to store a pair. So let's say pair of int comma int, and priority queue, in priority queue will be needing the minimum priority queue. So for that we have a vector of pair of int comma int, and the greater pair of int comma int, and one more, pq. So this is the syntax. That's how you define the priority queue in minimum priority queue in C++. So inside the pq we need to push the source and the distance, that would be 0. So I'll do pq dot push. I am pushing the distance because I want this to sort according to the distance, not according to the vertex. So I am pushing 0 and the source. So after doing this, what else do I need? I need a distance vector where I will update every minimum distance. So I need a vector of integer type, and let's call it distance. It will be of size capital V, and I'll initialize it with maximum, int maximum, that would be the infinity. So we said that the source node's distance would be 0. So let's do this. Distance of src will be 0. So we did this, and after this we'll say okay, run this loop until the priority queue is not empty, and every time we'll take the top element of the priority queue, and in priority queue we'll be having what we'll be having we will be having one distance and the other is node. So let's do this. And distance, the distance is of the previous, how much it has taken. So let's call it the previous distance, and previous distance pq dot top dot first, and after this I need the node pq dot top dot second, and I'll check for its adjacent vertex. So I'll check for it auto of E and adj of node. I'll check for its adjacent vertices. Now it will give us two things, the vertex and the cost. So I'll store that. So I'll say okay, int let's call the vertex v, and it would be e comma first, and int cost, that would be e dot second, and after this I'll check if the previous distance and the cost that I have, if this is less than the distance that I have assumed, of the node, not the node, sorry, of the vertex, then I'll update it. So I'll update the distance of that particular vertex to previous distance plus cost, and I'll push q dot push. I'll push the distance of that vertex and the vertex itself. So after doing this, so what else are we missing? Okay, we forgot to pop this. So after doing this, what we need to return? We need to return the vector, right? We need to return the vector. So in the end we will return the distance vector. So let's see if it works or not. let's see. Okay, it's working fine. Let's try to submit this. So yeah, it got accepted, and the time complexity for Dijkstra algorithm would be big of it would be big of e log v. Why e log v? Because priority queues insertion takes log n, and insertion and also the when you pop that when you get the top, so it takes log n, and we are doing it for every edge, so that's why every edge we are inserting and we are popping the top element, so it will take big of e log v, and the space complexity would be big of v plus e because of the priority queue. And if we consider the adjacency list, if we don't consider the adjacency list, then it would be big of v. So this is it for the video. Thank you for watching.